Okay, so today we're gonna be doing something with induction. So here's what we're gonna do. We're gonna prove the formula for the sum of squares right here by induction. So induction, when I first learned about it, it just made so much sense. A lot of people talk like it's this magic, mystical thing. It makes so much sense though. Especially if you've done programming or something, something a little bit more with discrete math. So here's what you do. First things first, you show the base case, right? So you show that this formula works for some base case. So let's say 1. So we plug in 1 and we see that, yeah, it checks out, it works. You can also plug in 2 if 1 seems a little bit too special for you, but 1 is perfectly fine. Next up is the inductive step. So assume that it works for n is equal to k, then you have to show that it works for n is equal to k plus 1. And what you do here is that if it works for n is equal to k, it works for n is equal to k plus 1, right? So you start with it works for n is equal to 1, and the inductive step will then show that it works for n equals 2. Then the inductive step will show that it works for n is equal to 3, and on and on and on. So that's how you can use induction to prove it. So let's go ahead and work on this. We're going to show that it works for n is equal to k plus 1 if it works for n. So let's get started. Let's do the second part. So plugging in n is equal to k plus 1, we get the sum from I is equal to 1, I squared, and n is k plus 1. Right? This is the same thing as if you split the sum, so you get k squared plus the sum as I goes from 1 to k of I squared, right? And we know this formula works for n is equal to k, so we'll go ahead and plug that in. So we get k squared, and then plus, we'll plug this in. So we get k over 6 times k plus 1 times 2k plus 1, right? And our goal is to show that this is going to be equal to if you plug in k plus 1 in here, right? Okay, so let's go ahead and see. So we have to show that this is equal to k plus 1 over 6 times k plus 2 times 2k and then plus 3 over here. And actually, if you do that, we'll see that it actually does work out, okay? I won't go through I'll leave the rest to you to just do the algebra to show why this equality is true, but for now we'll just say that this, if you do the algebra, we do end up getting that. So we did our proof, and now